Hi, today I'm going to be discussing this demonstrator module here we made for the Airpel-AB cylinder. The Airpel-AB uses a frictionless piston inside of an air cylinder configuration, and this I'm holding here is an example of a finished Airpel-AB. This is a 16 millimeter bore, 80 millimeter stroke Airpel, and rod comes out of the front nose with some clearance, and there's also a ball and socket joint at the end of the rod. The idea is to provide a pure force without friction. And to demonstrate it, we came up with this demonstrator here to show what's happening inside the Airpel-AB. Now, inside this particular Airpel-AB, this 16 millimeter bore, is the working cylinder, Pyrex glass. So it's ideally suited because of its transparency to see how the piston's working. So this demonstrator here has this same cylinder inside there. It's a little hard to see, and then there's an outer Lexan tube. So what we have for the demonstrator is a small aquarium pump. It puts out about 2 psi running through a line and then a filter to a needle valve so we can change the pressure to the underside of that piston. And right now I'm going to plug in the aquarium pump. So if my assistant, can you please plug in the aquarium pump, please? Okay, just takes a second to get the pressure up. I'll adjust the needle valve here to add a little more air in, and you can see we've already generated enough pressure to counteract the weight of the piston rod assembly here. It works out to about 1 psi, or very approximately 0.01 megapascal, a little bit less than that. So the demonstrator isn't that impressive. There's no way to show that it's frictionless. So we came up with the idea of using this very thin crossbar. And the idea is if the piston is frictionless along its motion of axis, it's also going to be frictionless when rotating about that motion of axis. So we have this just way to put a small torque around the piston, and you can see it spins quite freely. And I'm going to try to zoom in a second here. You'll see the noise of the motor of the digital camera, and it spins quite happily. It does slow down eventually from the viscous air drag between the piston and cylinder. It's a very thin film there, but it really only stops when the piston bottoms out. And that's what it just did. So that's the idea. So the point of the demonstrator is not that we're providing frictionless rotary motion. That's just a side benefit which is probably not useful to our customers, but just as a way to demonstrate the frictionless nature of the piston, we've come up with this system. And so that's pretty much what's happening inside of the Airpel cylinder. When you put pressure in it, typically you're putting much higher pressures than 1 psi. And that's what we have. So thank you for watching.